All right, welcome. You've made it to algorithms. Hooray. We'll talk a lot in this class about what is an algorithm, what kind of algorithms can we create? How do we say that an algorithm is good at its job, bad at its job? How can we prove that an algorithm does what we say it's supposed to do? That's the sort of thing that we're looking at. In terms of what an algorithm is, you've probably heard this a bunch of times, but in case you haven't, an algorithm is just a procedure that we use to accomplish a specific task. So one of the common analogies you'll see is a recipe. If you've got a recipe for chocolate chip cookies, there's some input, which are all your ingredients, and then there's some procedure, which is, put the dry ingredients into a bowl, mix it around, put the wet ingredients into a bowl, mix them around, combine the two, put it in the oven. And then at the end, you have your output, which are your delicious cookies. And pretty much any other process that you do is also an algorithm. If you have some sort of itemized procedure of this is what I'm going to do to accomplish this task. So like laundry it can be an algorithm where you have your dirty laundry, put it into the washer, put it into the dryer, and then you fold it, and then you've got your completed task. So yeah, this is basically what is an algorithm, where we have some input, and then we've got, here's the steps that you take, and then we've got the output. At its bare bones, this is what we're talking about this semester. So at the end of the course, you're going to be able to identify algorithms in everyday life. You're going to be able to recognize common categories of algorithms. So if you see something in the wild, then you can say, oh, that's a greedy algorithm. Or one of the ways you solve this is with dynamic programming. You'll be able to understand and be able to simulate or reason about the common algorithms. We'll go over a lot of them. You'll be able to reason about algorithmic complexity and correctness. So those are the two things of, is this good at what it does? And is it correct? Does it do what I expect it to do? And then we'll have a lot of group project opportunities. So you're going to improve your presentation skills and your group project skills. So buckle up. It's going to be fun. Okay, you've made it to Galileo 114. Hooray, congratulations. We go till 3:10 on Tuesday, Thursdays. The class is in person. So I do record it and I put it on YouTube, and there will be a page on Canvas where you can like look up, here's the date, and click on the link and watch the video. The video will generally not be edited. I'll just like hit record in class, and then it'll go until at the end of class, I hit stop record. So if there's like group activities, it'll be quiet in the video for a while. That's just because I don't have the energy to go through and edit it out. If you do need, like, if you're sick, but you want to still come to class and get credit, I can send you the Zoom link. But I request that you email me first so I can send you the Zoom link. And that way I know that you're planning to attend on Zoom. And that helps me to like plan ahead for class to know how many people are going to be here. Anything else I want to say about? So far, so good. The textbook for this class, where did I put it? The Algorithm Design Manual. It's available probably in the bookstore, also on Amazon. I recommend Abe Books is my favorite site to buy textbooks and books in general on, because it's generally cheap and fairly fast. Previous editions are okay. They may just be missing some of the newer feature. I think the newest version has a bunch of like problems and like a lot of activities, which could be helpful. But if previous edition is the cheapest one, then go for that. There's also a bunch of resources for algorithms and understanding algorithm analysis on the internet. And there's so many other textbooks also out there. So if you're not understanding something, I really encourage you to like go to the library and go to the algorithms section and just like pull things off the shelf and see if the topic that we're looking at is in there. Guarantee you it will be. There's a lot of resources out there. So I recommend the slides and the homework are roughly going to follow the structure of the textbook. So I recommend that you buy the textbook, but you don't have to. So in terms of what's expected of you, please come to class. We'll be talking about things, and I'm hoping that it can be really interactive as well. Like you've got the packet that we'll fill out together, and you also get to talk to your peers. If you are sick or have some emergency, like that's fine. Just send me an email. If you're sick, just wear a mask maybe, or email me and show up on Zoom. That's fine. There's like 30 people and we're all crammed in here. So just be cognizant of your classmates around you. Yeah, so the packets that you have in front of you will typically, you'll just like hand them back to me once we're done with each unit. So don't lose it, hold on to it and bring it back next time. It's also available on Canvas if you need it. You'll make, so part of the idea I have for this course is I want you to make videos describing different types of algorithms. So as we go through the units, the first few units are mostly problem sets as we get acclimated. But once we get into the meat and potatoes of this class, I'll assign you groups and then you'll make videos describing, I'll give you, here's an algorithm, talk about it, describe it. And so the idea for the video is it'll be roughly three-person group, where someone is the architect who writes the script of here's how the algorithm works. And the architect also can design examples to use. There's a programmer who, once I've assigned you the algorithm, you can write the code for how the algorithm works. And then there's the videographer who's responsible for maybe filming the architect as they explain things and editing everything together, publishing it. And the idea is if you're a videographer one week, you can be the architect the next week and rotate roles. The idea is I'll have I'm still working on how to set this up, but you'll have access to all of your classmates' videos and they'll have access to your video. And so you'll watch your classmates' video and write some short responses to what they said or the topic that they did. I want to talk about this and then I'll go one back. The videos that I'm envisioning, less than 5 minutes. So not super in-depth, but you do need to know what you're talking about. In terms of visibility, so I'm expecting the videos will be either public if everyone agrees to it, or unlisted in case there are privacy concerns or anything like that. Unlisted is the default, and so only if all the group members agree can you make the video public. So if you make it public, it could be good, like, I don't know, it's part of your repertoire. So yeah, but in case there are any concerns or anything, the default is just make it unlisted. And then like don't share the unlisted links outside of class unless the video is public. Okay. So going back, the class time will include some lecture components and like interactive problems. So we've got the packet there. So the idea is we're going to bounce back and forth between presentation, do something, presentation, do something. So hopefully that's more engaging and the Worksheets are also interactive, like talk with your neighbors. The room is really well set up for that. Yeah, so whenever you're in a group situation, just a reminder to share contact information. And if someone sends you a message about an assignment, make sure that you respond as soon as possible. And as always, communicate. That's the moral of the story. And it's also a good way to approach being in my class, where if you have something come up or something's not working, if you communicate to me, we'll find a way to make it work. If you don't communicate to me, then I'm not going to know what's going on. And then maybe you'll get like if an assignment is late and something's not going right, then I might have to grade you down. So communicate, communicate, communicate. Have the slide for why are we doing videos? One thing I learned about teaching the first couple times I've done it and continue to learn, teaching is learning, and learning can involve teaching. So in order for me to teach something, I need to know it really well. And that's the goal that I want for you in this class. I want you to know the algorithms really well. And so being able to present those topics in something like a video will help you build those skills of being able to know what's going on and explain it to others. Yeah. Being able to explain things, being part of a team, all really great skills that you'll use in industry or in whatever job you go into next. Some homework sets are, some homeworks are going to be problem sets, especially as we get started. Those I expect are to have individual submissions, so everyone turns in their own paper, but I expect them also to be collaborative. So like, yeah, so like work with your friends, your neighbors, and come up with solutions. And then just at the end, write the names of who you worked with at the top of your paper. And that's good. Okay, in terms of grading harshness, I'm going to warn you. In general, I'm fairly lenient, but for this class, there's 30 people, and I'm warning you that I'm going to be harsh at the beginning to help establish expectations. Of course, as things come up, if you communicate with me, then we can work something out. But I'm going to be harsh at first. Yeah, the moral of the story is if you start early, one thing, you will finish early, and then everything will be fine. But if you start late on things, then you'll finish late and you will be panicked. And that's not good for either of us. Okay, a very important thing, if you're booking flights for May, don't book a flight for Thursday afternoon. Our final exam is Thursday, 1 to 3. So this might be one of like the last times that final exams happen. That's us. So don't leave town early. Okay. Let's now go to the syllabus. So I think you have access to simple syllabus in Canvas. I have to open it in a new window. Nope, wrong one. There we go. All right, so now we're just gonna go through and catch everything that I missed. My office hours, my office is just down the hall. If you go out here, take a left, and then take a right at the Bank of 103 offices, I'm in there. You'll know that I'm in there if the light's on. And yeah, I'm generally available if you just want to stop by and ask a question. If you're wondering, oh, is she here? Chances are yes, come and drop by. If you want to book an appointment, so my office hours are 1 to 3 on Mondays and 10 to 12 on Wednesdays. And if those times do not work for you, or you have a question some other time of the week, then I have an appointment schedule where any of these times, they're set up for 15 minutes, any of these times, I'm guaranteed to be available. So I make sure my Google Calendar is updated so that you can just book a time here, and then it'll send you an email, it'll send me an email, and I'll be in the office. So in case you want to set up some meeting, just do that. We're good to go. Okay. Talking about algorithms. Program learning outcomes, these are like for the whole computer science program. Kind of talked about, here's what you're going to get out of the class. The class is in person. Email me if you plan to not be here. Talked about the textbook. Talked about other ways to get help. We talked about Packet. We talked about the problem sets. We talked about videos. Did not talk about project. There will be a project assigned in, what did I say? Week 5. Just to make it available to you so you can start working on it. And the project is really open-ended. So if you know, here's the things that we're going to cover, then you choose one of our topics, and then you go out in the real world and you choose an application, and then mash them together and write some code, have some output, and then present it. So you will have to present it. One of the options is just do it in class. The other option, for some amount of extra credit, I think it's like 15 or 20 points, is you can showcase it at the Student Research Conference, which happens, I believe, in the Soda Center, the last week of classes. So that's a good opportunity. You can put it on your resume. So that should be fun. We're going to have 2 exams, the midterm and the final. The process for the exams is it'll be in person, no computers, haven't decided on notes yet. But you'll come in here, your bags and stuff, and your phones are on the table or at the front of the class, and then you just work on the exam, paper and pencil. If you can also take it in SDS as needed. Yeah, this is roughly the breakdown. Assignments are 75% of your grade. The project is 15%. Exams are 10%. And since I'm making new slides and assignments for this course, I can't really say here's the firm schedule. Roughly, this week we're looking at just the introduction. What are we doing here? Hopefully next week we'll look at how do we analyze an algorithm, and then we'll get into data structures where you'll most likely have your first video. Then we'll look at sorting, and then we go into all of the fun stuff, looking at like divide and conquer algorithms, hashing algorithms. How do we do graph traversals? And so we'll see how long each one takes and adjust as needed. Roughly, I'm planning to have a midterm exam for whatever topics we've covered so far, right before spring break. Product is assigned roughly in week 5, just so you can start working on it. And then projects are due by the end of the last week of classes. And then we have the final exam, which again is Thursday afternoon. Okay, we talked about this part. Grading scale is the same as pretty much every other class you have ever taken. Technology stuff, please bring a computer to class if you can. Also bring something to write on, because like we'll have packets and a lot of algorithms. The way that you can really understand them is sit down with a paper and pencil and draw it out. Like sometimes it sucks, but that's one of the best ways for you to be able to understand and learn what's going on. So I also recommend paper and pencil or tablet and pen, your choice. If you don't have access to a computer or a reliable computer that you can bring into class, because I know like some of you may have things with like old batteries. I think there's like plugs probably along that wall, one up here. If you don't have access to a reliable computer, come talk to me. There are resources available like the STEM Center, library, and SDS have some things where you can like rent a computer for a whole semester. So if that sounds like something you need, talk to me and I'll refer you to those offices. Okay, I wrote an AI slide. Wait, I think I didn't copy it to. I don't think I copied my AI slide. There we go. Okay, so my policy on AI is that you're hopefully going, if you're a computer science major and you're hoping to get a job in industry, you're going to go into an environment where they expect you to know stuff about algorithms. And so it's entirely possible because ChatGPT is like really good at introductory coding elements and explaining things in just like normal people text. So if that helps you to understand the topic, I'm okay with that. However, it's really important that you be able to think critically about algorithms and being able to solve problems when you show up in an interview and they're like, how do you do this? You need to be able to know how to do it and not have ChatGPT open in another window of how do I do this? Please help. So the other thing is, because you're students, you're learning. When I took this class here at St. Mary's, I didn't really know what was going on at first. It took several iterations to it took several iterations for me to figure out, okay, now I understand this is what algorithms is. This is what like breadth first search really does. So it takes time. I'm not going to expect you to turn in like absolutely stellar, perfect work. Like that's not part of the learning process. I do expect you to make an attempt. The thing about AI is that when I get a like perfect code or a perfect response, it's easy to tell because like I said, I'm not expecting you to be perfect at this your first go around. So if you do the work yourself and put in the work needed to show that you're trying to understand this, then that's good in my book. So that's kind of my policy. Yeah.
So like with like having like better presentation for like to put out comments to.
Say that again.
Is it important to have like comments to like help you like see it?
Yeah. Comments like in code or just in general? In code, yeah. So comments are really important. Like you don't need the thing about comments is you don't need for like if you define an integer, you don't really need to say like this is an integer. The important thing is like what's the integer for? Or if you're doing something super complex, maybe have a few lines of comments summarizing this is the super complex thing I'm doing, and here's what it means, and here's how it helps me get this done. That's basically what I'm looking for. My other thing is if you do use AI for something, you're responsible for two things. The first thing is you're responsible for the content, the correctness of what it gives you. Because if you've heard, it can hallucinate things. Like if you ask it for book recommendations, maybe some of the books are not real. And so if you just like copy paste that, then if one of the books isn't real, then oh well. You may have heard about there was an article where a lawyer used, I think, ChatGPT to write a brief, and some of the cases just didn't exist. And so that's really bad. The lawyer got in big trouble. So you're responsible for the content, the correctness of the things that you write. You're also responsible for the completeness. So let's say you're writing an essay about some topic and you ask AI and it gives you XYZ, but maybe another critical part of this topic is 1, 2, 3 over here. And if AI just gives you XYZ and you don't include 1, 2, 3, then that's a problem. Then your writing isn't complete. So you also have to make sure, did it give you everything that you need to talk about? So that's also something to keep in mind. I have an example. Recently I was trying to work with ChatGPT to give me like a spreadsheet equation because I wanted to have like a list of students and then I input like a number and then it'll give me groups of this size. And so I asked ChatGPT just to get me started, and the process was really frustrating for me because it would like remember certain details that I wanted and then not give me other things that I told it to, or it would fix like some instruction, like the equation that it gave me would be correct, but the explanation would be totally wrong, or vice versa. So that's the whole thing. Like you have to make sure that the information that you get from it is correct and complete. Okay. All right. So that's my, there we go. That's my AI spiel. You're allowed to use it to get started on out of class coding. I'm okay with that, given the caveats that I just mentioned. You have to be able to understand what it gives you, because that's the whole thing when you go for interviews. You need to be able to understand the code that you write. If you don't understand it, then start over and try again. For in-class assignments, which are typically the packets, don't use them because we're trying to learn here to figure out what's going on. I ask that if there's any written things that you don't use AI, because again, especially for like the script for the videos, you need to be able to stand up and say, here's XYZ about this algorithm, and I would like you to be able to know what you're talking about. Any questions so far? Yeah.
We're only gonna be doing like code and pseudocode, or gonna be doing groups at all?
Yes, to both. So I will ask for pseudocode probably on like in-class activities or like an exam, when you don't have a computer. Proofs also, yes, we'll talk about it. We'll work on it together. There will be like actual coding components for like the videos or your project. So yeah. That's a good point. In terms of language policy, my policy for this class is you can use whatever language you want as long as I can read it. So choose your favorite language, go with that. We talked about attendance. Make sure you communicate with me. Initially, I'm going to say no late work, but as the semester goes on, make sure you're talking with me. Yeah, come to class, ask questions, talk with your neighbor. academic integrity, this kind of follows from the AI conversation. Do your own work. I would like, so for the problem set homeworks, it's individual but collaborative. So as long as you write, I worked with person A and person B, then I'm fine with that. But yeah, if I do see something that makes me suspect, then we have to have a conversation. And depending on how that conversation goes, I may have to escalate it. I don't want to do that. You don't want me to do that. So just do your own work. And then we have a lot of the boilerplate things. Be kind to each other. Think about how your words affect others. Just in general. Good skill for life. Honor Council, student conduct, Title IX. Library, great. There's lots of books on algorithms in the library. For SDS, if you need accommodations or if there's something that the SDS can't provide, but you think I can do it, come talk to me. I'm happy to work out a situation where you can succeed in this class. That's what I want you to do. I want you to succeed. I want you to learn. I don't know for tutoring. Okay, since this is like a senior level class, there may not be tutors at the STEM center. I'm seeing a shake of the head. So you're all in this together. Talk to each other. Your peers are your tutors. And then if you need further clarification, come reach out to me. Okay. Meal pantry, I see. Okay, I think that's pretty much it. Any questions on the syllabus? Cool. All right, so we did that. Let's look at the schedule. Okay, we've distributed the packet. And then we'll look at the introduction. There we go. Okay. All right, so what time is it? We've got a little less than an hour, so we'll start now and go as far as we can. All right, so here's what we're going to look at in this unit, chapter 1. We're going to talk about what's an algorithm. We're going to look at, here's some examples that you've seen before. We're going to look at how do we specify a problem? How do we express an algorithm? So this includes like pseudocode or actual code. We're going to start reasoning about correctness, talking about different ways that we can prove something. So like induction or contradiction to prove something, or for if we're trying to disprove something, we'll look at counter examples. Has everybody, how do I want to phrase this? Who here has not taken discrete math? Okay, fair amount of people. That's okay. We'll work through it. Discrete math gives you a lot of the theoretical skills. So like tell you here's how to prove something. So we'll go over it a little bit. And if you're having problems, I encourage you to talk with your classmates who did take that class, and that'll help you move along. Then the other part of this chapter is we're going to model, figure out how do we model a problem. So that looks at how do we do abstraction? What sort of data structures, without going into too much detail, what sort of data structures can help us do this? We'll briefly touch on recursion again, and we'll look at estimation. So this structure kind of roughly goes along with chapter 1 in the textbook. And there's more information in the textbook that I kind of pick and choose. Here's what I want to cover in class. But the things in the textbook are also really helpful if you want more information. Okay. Okay, so we talked about what an algorithm is, which is basically we've got an input, some set of instructions to do X, Y, and Z, then we have an output. So here's an example for an algorithm. Let's say one of the lights in the classroom is out or the lamp doesn't work. And so first we check, or maybe we could use the fan or something. Is it plugged in? If it's not plugged in, then the output is clear. We have to plug in the lamp. And then we have to check, is the bulb burned out? And if the bulb is burned out, then we have to replace the bulb. Otherwise, then there's something else going on and we have to repair it. So it's a series of steps that we ask different questions. And then as a result, hopefully the output is the lamp works. Okay, so we talked about like the recipe. So your first your first packet problem, I would like you to work like you're all facing each other. So work with your neighbors, talk it out. What are the steps involved in accomplishing the 3 tasks of making spaghetti, putting gas in your car, doing laundry? Up to you. Up to you.
So keeping it simple, I'll say gather ingredients, pot contains boil water for pots and noodles, and then insert them. The specific sauce and ingredients and hard sauce and noodles. Yeah. Necessary information, so well, afterward, that'll be afterward, right? Like, you utilize it. The game is doing something.
All right, 2 more minutes.
That's gonna be the problem with the thing, guys.
Yep.
I don't know what you.
All right, try and tackle at least all of them. 1 more minute left. I'm not expecting anything to be perfect and correct, but at least make an attempt if you can. All right. Okay, so let's share a little bit. I know you weren't in like specific groups, but can I have someone volunteer? What were the steps that you said it took to make spaghetti? Anyone, go for it.
It can be kind of simple, but gather supply and ingredients, so like either pasta. Set spot, make your sauce. With all the other things like that, and combine the two.
Yeah. Okay. Anyone else have any ideas? Did anybody else do something? Go for it. No.
Yeah. Okay, so we make the spaghetti, we grab the pot, put water in the pot, stove. On the stove, and you put the water to boil it. And then it's pour out there. We do the sauce, bring the pasta, add the sauce and pasta and stir the pot.
So, okay, so if you're doing like a super itemized way of doing it, my question then is, do you just like eat it straight from the pot?
We're just making spaghetti, you don't have to serve it.
That's an argument. See, that's the thing about algorithms and just like the reasoning about things in general. If you can argue something, and I can buy it, then you're good to go. Yeah, so if you argue that like, oh, we're just making spaghetti, we're not serving it, then like putting it on a plate and like saying, okay, now you can eat, then I would say that may be a fair assumption based on the instruction of make spaghetti. Anybody else have fun things? How about anyone for putting gas in your car? Maybe someone from this side of the room. Go for it.
I think you first start the car, then turn off your car. Then you open the gas tank on, insert your card into the gas machine, take out your card, fill out the nozzle, and then plug it at the gas side. And then insert the nozzle into the gas tank, then put that nozzle at your desired amount, and the battery can fire for like the battery. And then you just put the nozzle and then put it back.
Yep. Awesome. Doing laundry. Anyone come up with something particularly exciting? Okay, cool. If you didn't do that, that's okay. The main thing I'll grade your packets on is completion. So making sure that you have something for every question. For stuff like this, where there's like different options, I don't necessarily expect that like you got to absolutely everything, because there's a limited amount of time in class, but as long as you made an attempt, then I'm good with that. You can also always, after class, go through and like add notes or finish things if you want, because that may help your understanding. And a lot of the packets can also be like practice problems for quizzes or exams. So don't lose these. These are really important. And your answers are really important. Okay. So you've seen algorithms before. One of the common ones we learned in CS2 is the like sorting algorithms, right? So taking a jumbled order of things and making it ordered. What other algorithms have you seen before? Either in class or maybe in real life? What do you think? Yeah. Search algorithms, yeah. Anything else? Yeah. Social media, yeah. Scrolling on TikTok or Facebook. I don't use Facebook anymore. Yeah. Majoring in page ranking algorithms. Yeah. Anything else? Yeah, so you've seen algorithms before, and we're going to look at a lot of big categories of algorithms. so that you'll like understand the big idea of how do we do some of these things. We'll look at some really famous, important algorithms that you as a student of algorithms need to know going forward. The first thing that we'll talk about today is correctness. So like, why should we care that our statements, so let's say we have a statement, insertion sort produces a sorted array. So if you remember insertion sort, it's where we have like a sorted subarray and we go through the array and we pick the first thing that's not sorted, and then we put it in the correct position. So we go through and we pick, okay, this is my new thing, I'm going to put it where it belongs. This is my new thing, I'm going to put it where it belongs. And so we can make a statement about insertion sort. We can say insertion sort produces a sorted array. That's a statement. It's either true or it's false. Generally, we would like to say that it's true, right? Because we want, when we say insertion sort produces a sorted array, that's the whole idea, right? But how do we know that it's correct? Some of the options we could say it's correct because obviously that's the whole point of insertion sort. Say it's correct because I'm a computer scientist. You can trust me. I know what I'm talking about. Or maybe ChatGPT says this statement is true because blah, blah, blah. Are any of these, well, maybe ChatGPT gives the correct answer, but especially for the first two, are they extremely convincing? No, we need to have a proof to say this statement is true. We need to be able to say this algorithm does this, and I know that it does because here are my reasons. So for problem 2 on the packet, I think it's like fill in the blank definitions. A proof is it starts with a clear and precise statement of what we're trying to prove. So that's insertion sort produces a sorted array. That's our end goal. That's point B. We also so this is what we're trying to prove. And then we need to say, here's what we assume to be true. So those are a set of assumptions. And those assumptions can make or break the proof that you write. So, yeah, and that's kind of our starting point. That gives us the tools to say, here's our end goal. This is where we're starting. So that's point A. And then the third component of a proof is the actual contents of the proof, which is how we go from point A to point B. So setting up in clear steps that say, here's my assumption. Now I can say this. Now I can say this. Now I can say this until eventually we get to point B. Right? So a proof is just getting us from A to B. And the steps that you take in this chain of reasoning, those are the important parts. It's important when you do that you don't say, like, you don't jump immediately to, insertion sort is doing what I want it to do, or you don't skip steps. So taking things in small measured statements is important. We care about the line of reasoning. So I'm not going to expect that you write perfect proofs, but I would like your reasoning to be correct. Like, I expect mistakes, but I will tell you, like, if you write a proof and then I'll say, hey, you're missing this step, it's really important. That's some feedback that you'll need to take into account of, oh, maybe I skipped a step, or maybe I don't really understand what's going on and I need to talk to someone about it. The line of reasoning is important. And this is one of the benefits of being at a liberal arts institution. where you have experience in English and seminar, where you're trying to come up with arguments for things. And so those classes help prepare you for this. This class helps you prepare you for those. So it all kind of feeds into each other, where we're trying to tell a story that takes us from one point to another. And we're going to use those skills in this class. Okay, so hopefully you got all those definitions down. Anyone need more time? Okay. So, next we'll look at how do we specify a problem. So we'll go through the slide and then we have an activity. So we're going to need clear statements. Man, it's really raining. We're going to need clear statements of what our input and output looks like for an algorithm. If you look at pseudocode in a textbook or in a paper somewhere, chances are it'll say input is this, output is this. So you need to be able to say, here's what we're taking in, here's what we're putting out. If you have input that is like really super broad, you can have the freedom. I would really like to close this window, but my arms are not long enough. You want to try? Go for it, please. Got it. Yeah.
That one.
Okay. Yeah, so if you're in a situation where your input is super broad, you can feel free to reduce it to something that's manageable. Because you're the algorithm, you're the designer. So you have the freedom to say, this is what I want my input to be. This is what I want my output to be. So your job is to, it's really creative, this whole process, where you have the freedom to say, I want to work with this and not this. When you're specifying a problem, also keep in mind, what do you want the output to be? So like if I ask, what's the best driving route between campus and Target in Walnut Creek? Most people would probably assume the best is the fastest or the shortest route, less miles. But in this case, we would need to be specific, because we could say like the best could be the fastest, or it could be maybe the least amount of turns that like you stay on the same road for as long as possible. You could say maybe when the best route is not using the freeway. So like not getting on 24. You could say the best route could also be the longest, so that you could like pile in the car with your friends, turn on an album, and only arrive at Target when the album is completed. So best is subjective. So you're going to need to be able to define what best means for your situation. Okay, so problem 3, I would like you to kind of, you can just like annotate the things that we have here and say what's the specific task that we're trying to do in like a few words. What's the procedure, like which parts of the procedure? What's the input? What's the output? Go for it. All right, 20 more seconds, try and finish up. All right. So what's let's choose one of them. Let's look at Chipotle. What's the specific task? Yeah. Yeah, get to Chipotle. That's what we're trying to do. So the procedure for all of these, the procedure is like all of those steps. What's the input?
Like.
Yeah, so maybe like location. I would argue, yeah. Because the thing that is changing throughout navigation is your location. Like you're taking a series of steps to change your location. So that would probably be the input. And the output is ideally being at Chipotle. Yeah, let's see. What about study plans? This one's a little bit different. Yeah.
So specific task is to study topic, your boxes.
Okay.
Procedure is,
Mhm.
and your output is.
Being smarter. Okay, what do you think about Twinkle Twinkle? What's the input and output of Twinkle Twinkle?
How long for?
Yeah, maybe. I mean, like, anyone else have ideas? Or yeah, go for it. Go.
Maybe the note.
The notes, yeah. Or maybe maybe you're making a recording, or the goal is to like give a performance, and so the input is your like skill and technical ability, and the output is song is performed. And the steps that you take to accomplish that goal are you play, here are the notes that you play. Any other ideas? Cool. All right. Go through 310. Okay. So I think we're gonna get through pseudocode, and then I have a few finishing up things to talk about. But we'll probably end with the content of pseudocode today. So when we write an algorithm, there's different ways to express it, right? We can either write actual code that we can run, or we can write pseudocode, which is like a higher level version of here's what we're trying to do. Or we can like say it in plain text of here's what the algorithm that I'm designing will be able to do. Different ways to express the same idea. So for insertion sort, we have here's the actual code. And then we have the pseudocode, which is not, it's not code that gets compiled or executed anywhere, but it still conveys, here's how you do insertion sort. And then we have the introductory statement from Wikipedia, where it's just a paragraph of saying, here's how insertion sort works. So there's different ways to express an algorithm. So pseudocode, in particular, it's a language agnostic way of saying, here's what the code I want to do, or here's the algorithm, here's what it does. So it's not anything that gets typed up and then compiled, as it is literally. So like this code here, like the while could maybe work if you're working in Python. Swap probably doesn't. Pseudocode also allows you to write like a sentence if you want to. So it's, if you're asked to write pseudocode, I just ask that you don't feel constrained to say, just like write actual code. Sometimes a sentence is so much clearer for understanding for both me as the grader and you as the designer. So like if you're working with a set called V and you have another variable or something, or I think this is an array called A, then you can say assign each element of V to A. And that's a way easier, way more understandable way than saying for I from 0 to n minus 1, assign each variable X in V to A at location I. Like that was confusing. I didn't know what was going on there, but having a simple sentence is much better, much clearer. So, so pseudocode needs not every single detail because again, it's not code. You don't need a lot of like the introductory things. All I care about is what's important. Like what are the important variables that you're working with? There you can come up with like a lot of helper things. We generally don't need that information in pseudocode. It's just what's important, say that. Usually in pseudocode, we'll deal with variable assignments with arrows. Sometimes not. That if you've taken, well, you've all taken things. You know that assignments typically work right to left, right? If you have X equals 5, the value is being assigned to the variable X. And so that's why we use arrows that like go right to left. If you design like a while loop or a for loop or an if and else, you can say that verbatim. Like here you can see we use while, and that's fine. And then there's also an end while, just to make it perfectly clear, this is where we stop. Because you can use indentation if you want to, you don't necessarily have to. There's no real hard and fast rules for pseudocode. It's mostly how can you convey this algorithm in a way that makes sense. So if you can do that and make your steps very clear, then we'll all be happy. Yeah, so, and don't be afraid if you have like some super technical thing that you're starting to write out, just ask yourself, could I make this simpler? Could I write it in a more human-friendly, readable way? The answer is probably yes. So go ahead and do that. So all three, so coding, pseudocode, and just plain English. Oh, that's the other thing that I forgot. So you can write code in like source code, pseudocode, or just like a few sentence description, if the description is clear enough, sometimes that's perfectly fine. Like being able to write, here's what this code does in plain English, and that can go like as a comment in the top of your file. Great skill to have. I would argue that being able to express something in plain English is one of the most important tools. And the whole goal is you want to be able to convey the idea of what you're trying to design. So for insertion sort, unless you're maybe learning about it for the first time, it's a fairly simple algorithm. So maybe the plain text, simple few sentences, here's how insertion sort works. That's probably the best option to go with. Yeah, so the goal is to convey the idea, but don't make it too complicated. Yeah. Okay, so we'll take the next few minutes and work on problem 4 in the packet, which is some Python code. And I would like you to write it in pseudocode and then write the short sentence of here's what the algorithm is, here's input and output, how it works. So we'll go maybe for 5 minutes, depending on how it goes. 2 more minutes. All right, does someone want to give an example of let's just talk about the short sentence. Anyone want to give what they wrote for the short sentence? Even if it's incomplete? Who wants to read their sentence pseudocode? Go for it.
Program basically takes an input from the user and then creates an array and runs through like a series of operations and then determines the quote unquote.
Yeah, I think you can be more specific. What do you guys think? Like, how can we build on top of that?
The code takes a user input number and compares it against a random number and a random array. Determine.
Yeah, I think that's closer. Yeah, specifying that it's in fact an integer, I think is really important. Because otherwise, like, input from user, what does that mean? So maybe further restricting it, how could we further say this is the kind of input? What kind of input is it looking for? Yeah. Yeah, I feel like that's an appropriate amount of detail for our short sentence, because it says, like, it's not very an expansive source of input, but saying an integer 0 to 100. That seems appropriate to me to include in a short statement. Yeah, and writing your statement about algorithms gets easier with time. It takes a lot of intuition to be able to say, this bit is important, I should mention that. So as you write things, maybe, I don't know, exercise your best judgment about, is this the sort of detail that I need to include, or can I just gloss over this? Okay. I think. Yeah, okay, so we'll stop here for now. I have a few more things to talk about. Out over there somehow. Um. So in terms of Canvas, I'll be building it as we go along. Homework one, I'll post probably for next class, so you can at least get started on it. We may not have all the skills, but you'll be on your way. I don't want to share that. Okay. I just ask that before next class or as soon as possible, fill out lab 0, which should take you less than 5 minutes of who are you, what classes have you taken, is there anything you need me to know? The things you need me to know could be, I have XYZ that happens regularly, so I may not be able to make office hours, so I'll be booking appointments with you, something like that. Anything that I need to know that's pertinent to this class, let me know. Okay, see you Thursday. Fill this out as soon as you can. Thanks.